This is Math 139, Unit 3, Section 1. We're going to begin this unit by talking about rational functions, which are really just algebraic fractions, fractions that have variables in the numerator, denominator, or possibly both. In our formal definition here, we define a rational function as a function of the form p of x over q of x, where p and q are polynomials. The first thing we need to be careful with in a rational function is anytime we have a denominator, it's not allowed to be 0, since we know we can't divide by 0. That would make our fraction undefined. So we have to be careful not to allow the denominator to equal 0. That's actually going to be the, most important point as we start thinking about domain. So as I look at the first example, trying to find the domain of this rational function, I know that the denominator is not allowed to be 0. I can just solve that inequality. 3x can't be negative 2, and so x is not equal to negative 2/3. Just a word about the formality of domain. Really what we mean when we say that is that x can be anything except for negative 2/3. So really I should probably say x, it's rather the set of all x, such that x is not equal to negative 2/3. But in reality, most of the time we kind of abbreviate and just leave it this way. So there's a more formal statement. There's sort of the abbreviation which we'll typically use. Let's look at the second one. Once again, the denominator is not allowed to be 0. So in this case, that just says x cubed can't be 0. Since the cube root of 0 is 0, that just says x can't be 0. So the domain is all real numbers except for 0, or just abbreviating it, x is not equal to 0. In number 3, we'll start out the same way. We can't allow the denominator to be 0. And we haven't done quite as much factoring in the last unit, so this is going to be the unit to bring back all those factoring skills again. In order to solve that, I will try to factor the left-hand side. A sum of negative 10 and a product of 21. Think of negative 3, negative 7. So I'd have x minus 3 times x minus 7 is not equal to 0, meaning that x can't be 3 and x can't be 7. So the domain would be all real numbers except for 3 and 7. Continuing the same way in number 4, if I want the domain, I know the denominator is not allowed to be 0. And what this actually says is that x squared is not equal to negative 9. Now, in the first unit, we often solved equations like this by just taking the square root of both sides and allowing the right-hand side to become plus or minus 3i. In this unit, however, we are only going to consider real-valued solutions, so I'm not going to worry about the imaginary ones. I'm going to say essentially no real solutions, and therefore all real numbers would be the domain. I didn't get any bad values, no values that I had to throw out. At least not amongst real numbers. couple more. In number 5, same idea. We have to make sure that that denominator is non-zero. And let's see, this one's a slightly more lengthy factoring process. If we've got a sum of 8, and the product would be 12 times negative 15 is negative 180. See, I would think 18 times 10. I want the 8 to be positive, so let's go with positive 18 and negative 10. Would multiply to negative 180, add up to 8. So I'm going to use the 18 and the negative 10 to break apart the middle term. We have 12x squared plus 18x minus 10x minus 15. Not equal to 0. And then if I factor by grouping, I would have 6x times 2x plus 3 for the first group. And in the second group, I'm going to factor out a negative 5. And that would give me 2x and also a positive 3 again. And so everything looks good. Those matched up. I have the 2x plus 3, which I can factor out as the common binomial, times 6x minus 5. So a little factoring review there. Like I said, that's going to come in handy in this unit. So I have 2x plus 3 not equal to 0. And then I also have 6x minus 5 not equal to 0. Continuing with those, the first one gives me x is not equal to negative 3 halves. And the second one, x is not equal to 5/6. So my true domain would be all x values except for those two. All right, one more domain question, number 6. I'll start out exactly the same way. I know that I cannot have a 0 in the denominator. So that denominator is not equal to 0. And let's see, this time I would be looking to factor with a sum of negative 3 and a product of negative 8. I think I'm going to get stuck on that one. Product of 8 is 1 times 8, 2 times 4. That's it. And there's no way to make any of those pairs add up to 3 or negative 3. So factoring's not going to work here. And this time I am going to have to go to the quadratic formula to solve that. So again, the only real difference is it's an inequality. X is not equal to minus b plus or minus the square root of b squared minus 4ac over 2a. The opposite of b would be a positive 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 4 over 2 times 2. And let's see, under that radical, that would be a 9 minus a negative. What is that, 1632? I think that's going to be a 41, but let's just double check that. It was negative 3 in parentheses, squared, minus 4 times 2 times negative 4. Yeah, 41. Over 4. So just like over here, there are 2 excluded values values that x can't be, one with the plus, one with the minus. I'm just going to leave it like that. So that's domain of a rational function. We always have to look at the denominator and make sure that we don't let the denominator be 0. That always gives us the condition on the domain. And then usually the condition involves solving until you get down to the x values that have to be excluded. All right, we'll continue with the next part of this section in the next video.